It's 2 in the morning, you're half asleep, your mouth is dry, and you stumble to the kitchen, and you grab a glass of water, and it tastes incredible. Not good, not fine, incredible, like the best thing you've ever put in your mouth. But here's the thing, it's water. It's supposed to taste like nothing. So why does it hit so differently at night? That's not your imagination, that's biology. And the real answer involves your brain's reward system, a 24-hour chemical clock running inside your mouth and some genuinely wild physics happening inside that glass while you sleep. Stay with me, because this one goes deep. Before we get into the science, I want you to understand why this question actually matters. Your body interacts with water dozens of times a day, and yet most people have noticed, consciously or not, that nighttime water just hits different. Colder, cleaner, more satisfying. For a long time, scientists basically shrugged at this. Water is water, right? Wrong. It turns out there are 4 completely separate mechanisms working at the same time to change how water tastes at night. And none of them have anything to do with the water being special. They have everything to do with you. Let's go through them, one by one. By the time you wake up thirsty at night, you've been slowly losing water for hours. Every breath you exhale carries moisture. Your skin releases it constantly. You don't notice, but your brain does. Deep inside the hypothalamus, there's a tiny structure called the subfornical organ, and its entire job is to monitor your blood for signs of dehydration. The second it detects a drop, it fires signals across the brain. And here's where it gets fascinating. A 2020 study published in the Proceedings of the National Academy of Sciences showed that these dehydration signals travel directly to the brain's mesolimbic dopamine system, the exact same reward circuit that activates when you eat something delicious, hear a song you love, or connect with someone you care about. What that means is this. Thirst literally recruits your brain's reward system. A 2022 paper in Nature confirmed that specific dopamine neurons in the ventral tegmental area actually track your body's hydration state in real time. So when you finally take that sip at 2 a.m., you're not just drinking water, you are completing a neurological reward loop. That satisfaction you feel, that's dopamine. Your brain designed it that way. This one surprises most people. Your saliva is not constant. It changes on a precise 24-hour cycle, a circadian rhythm, and multiple peer-reviewed studies have confirmed this, including decades of research from salivary scientist C. Dawes, published in the Journal of Physiology. Here's what happens. During the day, your saliva flows more freely and stays relatively diluted. But at night, production slows dramatically. And as it does, the remaining saliva becomes more concentrated, higher in sodium, chloride, calcium. Your mouth gets drier, stickier, saltier. Then you take a sip of cool, neutral water. The contrast is enormous. Your taste receptors aren't just tasting water. They're detecting the difference between your concentrated, mineral-rich mouth and something completely clean and neutral. That contrast registers as intensely refreshing. And there's more. Research on circadian rhythms and oral temperature shows your tongue's sensitivity actually shifts throughout the day. Studies measuring taste perception at morning, midday, afternoon, and evening found measurable differences in how people experience sweetness, bitterness, sourness, and freshness, all driven by the time of day. At night, your tongue is essentially running on a different setting. Now, this one is pure chemistry, and it's genuinely cool. When a glass of water sits open in your room, it doesn't just sit there. It reacts with the air around it. The main thing happening is carbon dioxide absorption. CO2 from the atmosphere dissolves into the water and forms carbonic acid, a weak acid that slowly lowers the water's pH from a neutral 7.0 down to somewhere between 5.5 and 6.5. That's the same process that gives sparkling water its slight tang. In a still glass, it makes the water taste flat, slightly off, stale. At the same time, chlorine, added to tap water to kill bacteria, is volatile. Left in an open glass overnight, it evaporates. For many people, that removal of chlorine makes the water taste smoother and less sharp. And then there's temperature. Cold water suppresses your taste buds, particularly their sensitivity to bitterness and metallic notes. As the water warms to room temperature overnight, those compounds become more detectable. The same glass of water that tasted clean at 10 p.m. can taste vaguely mineral or earthy by 3 a.m. That's why same glass, same tap, completely different taste. This one is the most underrated layer, and it's psychological, but no less real. During the day, your brain is constantly juggling inputs: visual information, conversations, tasks, sounds. Taste is just one signal competing against dozens of others for your attention. At night, that competition disappears. No screens, no noise, no distractions. And sensory neuroscience is clear on this. Attentional focus amplifies perception. When taste is the only thing your brain is processing, you experience it more completely. So, to wrap up the everything said, water tastes different at night because your body and environment change at the same time. Dehydration activates your brain's reward system, your mouth becomes drier, and your attention is more focused. At the same time, the water itself slightly changes in chemistry and temperature, enhancing its taste and making it feel more refreshing. Thanks for watching. If you enjoyed this, subscribe for more videos that explain everyday science.